In this recording, we're going to learn about piecewise linear functions. Now, when you start seeing a lot of notation like you have here, sometimes your eyes can glaze over a little bit unless you have like a little hook to hang on new information. Like you can relate to this. You've seen this before. And I think, in fact, you have. If you've never been to the MOST, it's the Museum of Science and Technology, but I bet a lot of you have been there. It's down in Armory Square. Now, if you go to their website, most.org, you'll see a table like this where there's tons of information. I want to focus in on the fact that depending on your age, you pay a different price as a non-member. Obviously, if you're a member, it's all free, not interesting. Let's simplify this table a little bit and just look at this part here. So, depending on your age, you pay a different price for admission as a non-member. And what they consider a child is 2 to 11, and then seniors they consider to be 65 and older. So basically there's different pieces depending on your age. So we can represent this in function notation. Remember f of x, right? So we'd say f of x equals, but there's not just one price. It depends on your age. So there's actually a low price if you're a child, a little higher price if you're an adult, and then a lower price if you're a senior. So which of these you get to pay depends on your input, your x value, your age. Okay, so that's what we have here, the different formulas. Okay, and here's where we have the different domains. These are the domains depending on which age you are, you pay a different amount. So the first one is for the child, the adult, and this should be greater than or equal to 65. All right, and then in terms of a graph, you would have a graph where age is the domain and cost is the range, and you would see three different pieces of the graph: a short one for children, a longer one with an open circle, because once you're not 11 anymore, you have to pay the higher price, up to open circle of 65. Once you're 65, you drop down here and start paying the lower price for 65. So the different representations, the sort of table, the formula, and then the graph. So let's apply this a little bit. All right, so basically what we're going to deal with is piecewise linear functions in this lesson. So different equations with different portions of their domains. Okay, so this comes in two pieces here. Right? And our first task is to create a table of values based on this piecewise defined function. Okay, so I'll do the first one for you. I'll have you do a little work. We're subbing in -3 as the input into the formula. Okay, so we have to determine which of these domains is -3 in, and -3 is obviously in this one, so we would not even consider this, and we just do -3 minus 3, and that's -6. And you're going to proceed subbing in the x value, figuring out which of the domains is appropriate, and then applying the particular equation that's relevant for it. Okay, so I'd like you to pause, play the recording when you're ready. Okay, so I went ahead and filled in -5 and -4, but once we get to 0, now we're applying a new equation because 0 is part of the bottom formula there. And so when we sub in 0, we get half of 0 is 0 plus 4 is 4. And we're going to proceed to apply this formula for all the numbers that are greater than 0 up to including 4. So we're just going to proceed to sub that in. Here we're going to get 4.5 for x equals 1, and so on. Okay. So at this point, it says create the table of values, check, graph the function. So I'd like you to plot these points and then do what you think you should do in terms of connecting the points in a way that makes sense for this domain, then play the recording when you're ready. Hopefully you took time to pause. If not yet, don't play it till you've paused and made your graph. All right, the graph should look like this. Okay, so we have a positive slope right here up to the y-axis, but it's an open circle here because I'm not going to include 0. I'm not going to include this first equation for x equals 0, but I am going to include it, the second equation, when x equals 0. There's that little line underneath that indicates equality. and then the graph proceeds at a different rate, up 1 over 2, up 1 over 2, etc. It says to state the range. Okay, remember range is the y values, the set of all y values. So you're going to move from the bottom of the graph up to the top and indicate the range. Why don't you write that down? Play the recording when you're ready. All right, so we're going to start at the bottom. We've got negative infinity up to 3, not including 3. And then we've got another interval that starts out at 4 with a closed bracket and continues up infinitely. So for infinity, we always use a round parenthesis, and we just put a U in the middle, which means or, a union. So it could be either down here or over here, not in both. Now we're going to flip it around. Now we're going to give you a graph and ask you to come up with the definition, basically. Okay, so it asks you to write a piecewise linear formula and specify both the formulas and the domain intervals over which they apply. So that sounds kind of confusing. Basically, I'm looking for you to do something like we have here. Write this, which includes the formula and the domain over which it is relevant. Okay, so let's see how far you can get. Pause the recording, do as much as you can, and play the recording when you're ready. Okay, so hopefully you did something. At the very least, I hope you identified maybe the domains. So maybe we could start with that. All right. So we know there's 3 distinct parts, right? 1, 2, 3, we can see that. Maybe it would be easier for us to start with the domain part rather than start with what the formulas are for those 3 lines. So this domain goes from -8 up to -2. And the question is, well, what kind of symbol do I put on the -2? Because it's the same for this line as for that line. Which one is it like belong to? I don't know. It doesn't really matter. I would say just be consistent. You do not want to have x, a particular x value, defined for more than one definition. All right. In other words, I'm not going to include -2 on the first one and include -2 on the second one. I'm going to pick one or the other. All right. So the next one goes from -2 all the way up to +3. So I'm going to say it starts at -2, including -2, and goes up to +3, but not including. And then the final one is from 3 all the way up to 6. And it does include 6. All right, now we just need to figure out the 3 formulas. Well, there's one that's easy right here. This is a constant. This middle part never changes, and that's 4. Okay? Sometimes people put commas here to distinguish or to separate the formula from the domain, but it doesn't matter. I don't think we did that previously, so we're not going to do that right here. Just kind of keep everything lined up. That'll be fine. All right, now let's do this one here. We need to figure out what's the slope and what would be the y-intercept, the starting point. So the slope, we go up 3 over 2, up 3 over 2. So that's our rate of change. 3 over 2x plus, okay, the y-intercept, if I were to continue this up, basically continue this pattern, it would go up 3 over 2. It would stop right here at +9. So that's going to be our y-intercept. Now let's do the same for this other one. I'd like you to pause and play the recording only after you've come up with a function, a linear function, that includes both the slope and y-intercept. All right, so you can see the slope is down 2 over 1, so we've got a -2. And then if you were to continue this pattern all the way up, you would get to +10. So that's our formula. Thanks for watching.